it did to me yesterday. I was very upset. Well, I guess it was my fault. Okay, so we picked 24. In 24, we are asked to approximate E to negative, is it negative 0.015? Am I correct?
Yes.
Okay. So we have a bunch of things that we have to identify. We have to identify the function, we have to find x, dx, then find f prime of x, and that's it. We should write the formula one more time, which is f of x plus a little bit of x is approximately f of x plus a little bit of y in the form of f prime of x dx. So I have to identify all these. So what is the function that we are looking at? Very good. It's e to the x. So then e to the x prime is e to the x. Now we have to identify x and we have to identify dx. Something very close to negative 0.015. What would that be?
0.02.
0. Something that we can work with. Yeah, very good. And how much is dx?
So when you're looking for x, you're looking for a whole number?
Something that I can work with. Something very close to this. Because if this says negative 5.015, I'm not going to use 10. I have to use negative 7. Something that I can easily work with. And it's not far. It's very close because we know dx is very small. Very tiny. So if x is 0, how much is dx? How far away is this number from this number?
Positive 0.015.
Right, but negative. 0 minus 0.015 is minus 0.015. So 0 and negative 0.015 are very close to each other.
So is dx always negative then?
No, it depends.
When would it be positive?
So for example, if I have 26, what do you think dx is? If you want to look at 26 at the top of page 255, problem 26, what will be x? What will be x? Not the function. I'm asking about x. Okay, let's start with the function. What will be the function? 1 over x. What will be x? 4. 4. 4. X is 4. How much will be dx? Positive or negative? Say it again. Look at the problem and identify the x. If you said that x is 4, then what else can be in there? Okay, I got it. It's not clear. So we're going to do both together. So 1 over 4.002. So let's identify the function. Let's identify x. Let's identify dx, and then f prime. Which function are we dealing with? Good. Now you have to tell me f prime right away because we know that. We talked about it several times. What would be f prime? No. It's on the handout. We wrote it last night. We talked about it 3 or 4 times. Negative 1 over x squared. You have to remember these things. You have to redo the notes. Please redo all our notes before you do anything else. Good. How much is x then in this function? Well, obviously, this is 1 over 4 plus 0.002. What is x? 4. What is dx? That's it. Dx must be a tiny number. It can be positive or it can be negative. So this is an example in which it's positive. This is an example in which it's negative. So dx can be on the left-hand side of x or it can be on the right-hand side of x, meaning it can be positive or negative.
Can we practice one of these doing it as linear approximation, as a differential, and then linear approximation?
They are the same.
I know your answer is going to be the same, but and then also doing it in linear approximation with differential notation.
Right, this is going to be the same because the linear approximation.
I know the answers are going to be the same, but it's a different formula every time.
So the linear approximation is f of x, right, is approximately f of a plus f prime of a times x minus a, which will be dx. So this is this, this is this, and this is this. It's exactly the same.
So you can choose which one.
They are the same. I recommend this one
Okay.
because this is confusing for approximations. You have x minus a here, but this is basically dx. You have f prime of x, but this is what they say it's f prime of a. So this is the same. It's all the same. And this is the function you are looking at. I mean, if you want to use this notation, go ahead. That's fine. If you want to use f of a and f prime of a and x minus a, that's fine. But this is our dx, which is x minus a. This is our f prime of x, which we can rewrite in any other way. It's f prime of x or f prime of a. I'm going to plug in 0 in a minute, which is your a. Same thing.
So quick question. So say if it was
1 over
3.012.
right.
So x would be 3.
Right.
And dx would be 0.03.
Right. Yes. Yes.
But yesterday, didn't you say that if the question is written so that we have to use it in a certain notation, we have to?
But because I said differentials, and identifying this dx, you will identify this dx. So this is much easier than subtracting here and finding a and then finding x minus a.
Okay.
But if you're more comfortable with something else, that's fine. Yes.
So like if it's 4.098 and then you could do like, or like, say it was like closer to 5 and then you make it 5 and then you use the negative there for
I
dx.
cannot change the number. This is what we just did here. I cannot change the number. I'm thinking of something very easy, the closest possible I can get to negative 0.015. So I use 0. Because that's the closest. 1 is so far away, I can't use 1. So the closest number that I can work with easily is 0.
So if the closest number is above, then you use negative.
Then
for
your dx is a negative because it means that here's your x and you are on this side instead of being on this side of x. So if you remember when we looked at this, let me go back. So we had this picture. See? I had this picture in which I showed that x and delta x, I said p and q are extremely close to each other. So your point q doesn't have to be on the right-hand side of p. It can be on the left-hand side of p. And if your q point is on the left-hand side of p, then dx will be negative. It doesn't matter. As long as dx is a tiny number, not 1500. Because this line will not work anymore. And delta y and dy will not be close to each other anymore. If these two numbers are not, don't differ by tiny bit, then the whole idea collapses. So that's why p and q are very close to each other. So if it's on the right-hand side of x, then dx is positive. If Q is on the left-hand side of P, or the left-hand side of X if you want, then the little tiny dx, little change, minor change, will be negative. But the drawing stays. It's the same thing. If it's on the right or it's on the left, it's the same thing. Good questions. So now let's finish this. It doesn't matter what you use. If you want to use this, please use it. If this makes you more comfortable, use it. I think it's more confusing, but I'm fine with it. So coming back here, I have to use this. So I have approximately what? So this piece is this piece. So I wrote the approximation symbol, and now what should I write next?
You should write
Yes?
E2 0.
Exactly. Then I have plus. What should I write next?
E2 0.
Of course. And then I have this. And then multiplied by dx. How much is dx?
0.0.
Careful.
Oh, negative.
Right. Good. How much is e to 0?
1.
How much is e to 0 times negative 0.015? Negative 0.015. So what is this answer? So it's 5, it's 9, it's 8, right? 9, 0. 0.987 and 0.985, correct? Okay, so now let's check with the graphing calculator. Here it is. This really shows the power of calculus. So we are trying to determine E. Where is my E here? The sun is in my eyes. Okay. So I have E in parentheses negative 0.015. 0.015. And it should be as close as possible, or very, very close, to 0.985 that we got. But can you raise this to that power? No, you can't. Not by hand. But can you approximate it now with calculus? Yes, very easily. 1 minus this is 0.985. Extremely powerful result.
But when we're rounding this, should we round to the third?
You should write what you get. What you get, like 4 digits, maybe 3 or 4 digits, yeah. Because you want to compare and see how close it is. Good. So now let's also finish this one out. So is this clear? Better?
Yeah.
Perfect. Okay, let's also do this one, just to make sure that this is clear. Super clear. Okay, let's take a moment and work on this one. 1 minute. Do we have the answer? Or can we start? Okay. Okay, so the left-hand side is obviously 1 divided by 4.002. And now I will approximate it with,
1/4
correct,
plus
minus,
a minus.
because it's negative, yes.
1 squared.
1 over
1 over 4 squared.
16, very good. Multiplied by, that's it. So I will simplify as much as possible. I have to find the least common denominator. Now this is correct. This is the equal symbol. But this is approximately this. But from here I have to use the equal symbol. So the least common denominator is 16. Or I could simplify by 2, and maybe I should have done that. So let's say it's 4 minus 0.002. So this is 3.998 divided by 16. So now I go back to my calculator and just make sure that 1 divided by 4.002, and my number that I came up with, 3.998 divided by 16, is the same thing. It can get closer than this. Yes, yeah.
Do we have to show the word where we simplify?
This part, yes, it's the algebra that needs to be done. Yes, I should have simplified 0.001 and this to 8. Oh, thank you. Sorry about that. I should have simplified it, and then I should have had the least common denominator as being 8, and this multiplied by 2. So this would have been 2 minus 0.001. So it would have been a 1.998, 1.999 divided by 8, which is the same thing.
No, so what I was asking is, like, say if we plug in the equation, we put out the answers out there.
You mean with the graphing calculator?
Yeah.
I prefer an exact number.
Oh, okay.
So, or you copy everything. Yeah. So, are we okay with this type of problem then? Is it better? Okay, perfect, excellent. Next one.
So I have a question about 3.4.
Yes, let's go to 3.4. Very good. Any question? Anything you worked on? So let's solve everything now. So 3.4, yes.
So it was number 29.
Number 29, let's look at 29. 29.
Page.
So f of t, is this the one? E raised to, I think it's t times sine 2t, is it?
Yeah. So now my question was, if this, is it a function times or raised to a function?
No,
times a function?
E is not a function.
Oh, it's a constant.
Exactly.
But this would be e to the x, right?
Right, it's e to u.
Okay.
We have a formula for e to u. We don't have a formula for x squared plus 3x raised to tangent x. For this, we don't have a formula. But for e to u, we have a formula. Yeah. And it's on the summary. Page, those of 6 pages that I gave, the handout that I gave out. Okay. So if you want to differentiate this, we will get e to t times sine 2t multiplied by the inner function prime. T prime is 1. Sine 2t plus the first function times sine 2t prime, which is cosine 2t, times the inner function prime, which is 2. Is this okay?
So you said it's e to t sine.
It's a product. It's a product of 2 functions. The first function prime times the second function plus the first function times the second function prime.
So the functions are x, t and sine 2t.
It's a product of 2 functions. Yeah. This is the first, and this is the second. First prime times the second, plus the first times the second prime. Sine 2t prime is cosine 2t times the inner function prime. Is that okay? Good. Perfect. Other questions? Anything else that you did not get the answer to?
We have form or should we simplify it?
Say it again.
Can we leave it in that form?
Yes. What the only one thing that I recommend here is just rearrange this. I would write sine 2t plus 2t cosine 2t. This is everything you can do to this. There is nothing else. Good question. Next problem. Anything else that you would like to go back to? What type of problems we should focus on now? Okay, let's go back to section 3.1. Are we okay with the derivatives of polynomials and exponential functions? Do we need to practice that?
Not just some logarithmic.
Logarithmic differentiation?
Yes.
Excellent. Okay, so let me tell you where they are, and you can choose.
I got a question.
Yes.
23.1.
So this is an example. If you want to, we can work on that. Or they are on page 223, 39 through 50. 39 through 50, and the page 223. Yes, Ian, please.
From 3.1
You tell me what you want, and I'll go to that. Choose any problem you would like to, and
Oh,
we'll.
it's number 53.
53, page
Section
3.1. Perfect. That's good enough. Okay, so let's take a look. 53. Show that the curve has no tangent line with slope 2. We did that together in class. We differentiated, we set it equal to 2, and that equation was never 0.
Okay, so to differentiate it and after differentiating you move it to and you just solve.
Because that's the slope.
Yeah.
The derivative will give you the slope.
Okay.
So they say, show that this function never has a slope of 2. When you try to set equal the derivative to 2, you will say no solutions. The equation has no solutions.
So as I was doing that, I just wasn't sure.
Yeah, we did it in class. Oh, maybe you were not here when we did it in
The
class.
3, I think I missed.
Yeah, let's do it then.
4 and-
Yeah, that's fine. No, in that case, let's do it. So we have y equals 2e to x.
No, I know how to do it. I was doing it. I did it properly.
So when you differentiate this, you get 2e to the x plus 3 plus 15x squared. All these numbers. So there was, maybe we didn't do this one in class. No, I don't think we did this one in class. I'm sorry. Has no tangent line with slope 2. Okay. So did I copy the problem correctly? Is that the one? 2e to the x, 3x
Yeah.
plus 5x here. Okay. So when I said this equal to 2, 2e to the x, oh yeah, I remember now. Yes, it is that one. And I subtract 2 from both sides. Yes, it is that one. It's in one of the notes. Again, you will be so much better off if you would find the time to redo all problems we do in class. You will start not from here when you get home, but from here. That's my opinion. So 2e to the x plus 1 plus 15x squared equals 0. This is never a 0. This is a positive number. This is a positive, and this is a positive. A positive number cannot equal 0. So the equation has no solutions, which we conclude then that that leads us to the conclusion that this function can never have a slope of 2. Good. So let's go back to page 223. Any preference? Any preference for between 39 and 50? Any problem?
We start with 39.
Yes. So 39. Y equals x squared plus 2 everything squared. X to the 4th plus 4 everything to the 4th. this particular type of problem doesn't necessarily require logarithmic differentiation, because I can differentiate the product. A problem like this absolutely requires logarithmic differentiation because it's a function raised to another function and we have no room. So we can apply logarithmic differentiation. I don't disagree, but I don't fully agree with that part necessarily because we can differentiate this. But let's apply natural log. So then we have natural log of all this multiplied by x to the fourth plus 4 to the fourth power. Now the left-hand side is natural log y. Now I have to change this into a sum. Natural log of x squared plus 2 squared plus natural log of x to the fourth plus 4 to the fourth. Are we okay so far? That's one of the rules or properties of the log. And then I bring 2 and 4 respectively in front. Natural log y equals 2. Natural log of x squared plus 2 plus 4. Natural log of x to the fourth plus 4. And now I have to apply implicit differentiation, which normally I would have had not to, right here. But now I have to apply implicit differentiation. Be very careful on this side because this is 1 over y dy over dx. And then the right-hand side is 2 over x squared plus 2 multiplied by 2x and 4 over x to the fourth plus 4 multiplied by 4x cubed. And now this is not enough. I have to write dy over dx, that's one thing. Secondly, I have to find the least common denominator, and I have to completely simplify it into a fraction. So I think that this is more work than if we differentiated from the beginning without doing all this. I'm not saying we're not going to get the same answer. I'm not saying that this is not correct. I'm just saying for this particular problem, I personally would have not applied log. That's all I'm saying. So then dy over dx equals, I have to multiply both sides by y, so I have to put it here. Way more complicated, in my opinion. Then I have to find the LCD, which is this. I have to multiply 4x by x to the fourth plus 4. I have to multiply 16x to the third by x squared plus 2. So I got myself into a pickle, right? Because I have more work to do on this one. So 4x times x to the fourth, I have 4 x to the fifth, and then 4x times 4 plus 16x. Now I have 16x cubed times x to the second power, which is 16x to the fifth, and 4x cubed times 2, 16x cubed times 2, which is 32x to the third. Now I have to work on this and also simplify. So I will simplify one of this with one of the top. I'll simplify one of this with one from the top. And finally, sort of finally, we'll see in a minute, dy over dx equals x squared plus 2, x to the fourth plus 4 to the third. And let's see what we get in parentheses. I have a 4 and a 16, so this is 20x to the fifth. And I have a 32x cubed, and I have a 16x. So now I will factor out a 4. Can I do more than 4? No, a 4x. So dy over dx is 4x, x squared plus 2, x to the fourth plus 4 to the third. And then I have 5x to the fourth plus 8x squared and plus 4. It's a good problem. It's a good exercise. I think that just simply differentiating the product will be much shorter, though, for this problem. Now, let's choose among those that I have no choice. Anything between 43 and 50, I have absolutely no choice. For everything else, I have a choice. But for this one, I don't. For these 43 through 50, I don't have a choice.
Can we do
Which one?
50?
Yes. So natural log raised to cosine x. Any questions on this problem? Rihanna, is this okay?
You were saying you had a choice to do that.
Apply log or not. But between 43 and 50, I have no choice. There is only one way, which is logarithmic differentiation. So that was y equals, so this is problem 50 on page 223. And we have y equals natural log x raised to cosine x. It's a function raised to a function. So I have no choice, and I have to write natural log y equals cosine x times natural log of natural log. And now I will differentiate both sides. The left-hand side, remember, implicit, 1 over y, dy over dx. And the right-hand side is a product of two functions, and one of them is a function composition. I have to be careful. The first function prime, negative sine x times natural log of natural log x, plus the first function stays, times the derivative of this one, which is 1 over natural log, times natural log prime, which is 1 over x. Good pick. It's an interesting problem.
Wait, can you explain that again? I'm sorry.
Of course. Which one?
I guess the step going from natural log y equals cosine x times natural log x.
So I have the first function, I have the second function. So this is the function prime times the second function. The first function times the second function prime.
Okay, sorry.
No. I'll rather go back. So cosine prime is this, and I copy the second function, plus I copy the first function now when I differentiate this. Natural log of a function, natural log of u, is 1 over u times u prime. But u prime is 1 over x.
Yep.
I will rearrange it a little bit, but there is nothing I can do really here. So I will just write dy over dx. Now I have to multiply both sides by y, and I have it here. I have to copy that. Natural log x raised to cosine x. And now in brackets, I have negative sine x times natural log of natural log. And I will condense this into one fraction plus cosine x over x natural log x. And of course, I'm going to put x in front. Yeah, for this, in this situation, I have no choice. I have to use logarithmic differentiation. Okay, can I choose a related rates problem? Okay, on page 249, I don't remember if we did problem 27. It's one of your, I think, homework problem. Did you solve that problem? 27 on 249. Maybe it's not a homework problem, maybe I'm wrong. And can we look at that? Yes? Okay.
That was one, but it was hard.
Okay, let's do it together, but I didn't hear anyone complaining about it. So 27 on page 249. Did we do it in class? I don't remember. No, perfect. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute. What does this mean? Before I move on. Nope.
The rate, right?
Yes. Exactly. This is it has to be very clear. It's cubic feet per minute. It has to be dV over dt. Agreed? Okay, perfect. So the curvature is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. Base diameter and height are always equal. Perfect. How fast is the height of the pile increasing when the pile is 10 feet high? What am I asked to determine? Let's read the question one more time. How fast is the height of the pile increasing when the pile is 10 feet high? Just give me it so I can write it here. Can anyone tell us what we are asked to do? What we are asked at the end of the day? What is the answer going to be? Thank you. That's all I needed. When the height is 10 feet. That's all I needed to hear. Perfect. Excellent. Good. So how do I start? Where is my starting point? Of course, I cannot use this till the last step. So what do I do? Where is my starting point?
Finding dV over dt.
I have it, but the starting point is the volume.
Yeah.
Exactly. So what is the volume of a cube? Remember, it's 1/3 of the volume of a cylinder. Pi r squared h. How many variables we see here, which should be functions, actually? I see v, which is a function of time. I see r, which is a function of time. And I see h, which is a function of time. But I don't have any indication about r, other than the fact that they are equal at any point in time. So I need to eliminate which of these three variables. R. Very good. So what do I know? I know that h equals how many r's? 2r. Very good. So r equals h divided by 2. So I'm going to have to plug it in. So I will plug in. So the volume equals pi over 3, h over 2 everything squared times h. Therefore, I have v equals pi over 3. H squared times h will be h to the third divided by 2 squared, which is 4. Or v equals pi divided by 12, h to the third. What is the next step? Any suggestions here as the next step?
Differentiation.
Of course. So the left-hand side is?
dV over dt.
The right-hand side is?
H squared.
You just told me what we are asked to do.
Yeah.
So age is a function, it's not a variable. It's a function of time. So,
dH over dt.
thank you. Perfect. And now I have everything. I'm going to solve for dH over dt first. dividing both sides by this, but of course I'm going to simplify. So the top is dv over dt, and the denominator is pi h squared over 4 or pi over 4 h squared. I'm dividing by the quantity that multiplies dh over dt. Are we in agreement so far? All I have to do now is what?
Again,
Exactly. So dv over dt was given to us as being 30. Let's make sure that the measurement units are all correct. Cubic feet, and this is in feet. Okay, fine. So pi divided by 4 times 100. I'll simplify, and then I'll simplify again. And 6. So I have 6 over 5 pi. I will definitely approximate. Just making sure I simplify by 5. Yes, correct. So I'll put in the graphing calculator, and I have 6 divided by, in parentheses, 5 pi, close the parenthesis, and I get 0.382 approximately. What does this mean? 0.382. Measurement unit. Without measurement unit, I can't give full credit, please. Measurement unit for this. Depending on what we are trying to find. What is this? Good. So then the measurement unit is? Exactly. Exactly. It's a distance. Very good. Excellent. Feet per minute. Was it that difficult?
I think for me, the difficult part was
Yes.
the
Yes.
leading.
This is very important to me. When my students tell me this is the difficult part, then I may be able to address it better.
It's the most simplest part, I assume, is just the equation for volume.
You have to remember that the volume of a cylinder is the area of the base times the height, and a cone is 1/3 of that.
Well, okay, not remembering that equation, but like I'm going to have to find h. So set h.
You're not finding h.
Well,
You
not
are
finding h,
writing
but-
an equation in order to find dh over dt.
Okay.
Right. So once you have the equation, you establish the relationship between what we're given and what we're asked to find, then you will differentiate both sides, and you will get that dh over dt. So that's why I did as many problems as we could in the short amount of time we have in one semester about, that I can spend on one particular section.
Can we do one where it's
Yeah.
two objects going two different directions?
Yeah. Let's see. Yeah. If we find one here, spotlight. Man starts walking. 5 minutes later, woman walks. So, for example, 17. Let's look at the 17. We can do 15. 2 cars start moving from the same point. One travels south, and the other travels west. I think we probably did this one, but I'm not sure if it's the same. Number 16, a spotlight on the ground shines on a wall, and a person walks from the spotlight to the wall. So 15, 16, 17,
Let's do 16.
16? Okay, so let's do 16. Okay, a spotlight on the ground shines on a wall 12 meters away. So here is what I see. So this is problem 16 on page 248. So when I read something like this is what I envision. 12 feet. And here's the spotlight shining on a wall. On the ground, shines on a wall 12 meters. Sorry. 12 meters away. Okay. If a man 2 meters tall walks from the spotlight toward the building. Don't make me draw a man. I'm sorry. Okay. He walks this way. leaving the spotlight on the ground behind him. So imagine that the spotlight is right there behind me and I walk towards the building, 12 meters away from the spotlight, okay? So the spotlight, if it's dark in the room, the spotlight will create a shadow on the wall that changes as I get closer to it. It will be smaller. See, when it's right here behind me, I look like I am a huge person right on the wall. The shadow will be huge. But as I move away from the spotlight, the shadow diminishes, and now I'm as high as I am. Does it make sense? So this height will have a negative rate of change of the shadow on the wall. Okay. So let's go back. Let's read on. From the spotlight toward the building at a speed of 1.6 meters per second. 1.6 meters per second. Okay, so here's what I envision immediately. This is the distance covered by the person going this way. I'm going to call it x. So then what does 1.6 meters per second represent?
The speed of the walk.
Right?
So that would be
So what should I put in front of this? In front of 1.6 meters per second. What should I write?
dx over dt.
Thank you very much. Okay, we established that. How fast is the length of his shadow on the building decreasing when he is 4 meters from the building? So here's the shadow. From the person's head all the way to the wall. So what am I asked to find? I have to picture the shadow, right? Without picturing the shadow, then I don't know what variables or what am I doing, right? So then, what am I asked to determine? Let's read it again. How fast is the length of his shadow on the building decreasing when he is 4 meters from the building? What are we asked to determine in this problem? Of course, when he is 4 meters away from the building, I have to relate it to x because he's covering x. So when x is, if this is 12 and this is 4, then this is 8 meters. Very good. One thing I did not put in my chart, and I should have, is this height. How much is this height? 2. Now I will read the problem one more time to make sure that everything is correct and in place. And then I will think about what I'm trying to do. A spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall, walks from the spotlight towards the building at a speed of 1.6 meters per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? In other words, when he covered 8 meters. Good. Any suggestions? When you look at this picture, what will you say? Anything rings a bell?
Well, it's a right triangle, so it could be straight.
True, but you can't use trig because you don't have angles. You don't know this angle here. Something else, maybe.
You can choose
Yes? How is it called?
diagram.
Nope. Let me give you a hint. What am I saying with this symbol? It's not the approximation symbol.
Or similar.
Similar, very good. Similar triangles. By similar, we do not mean equal or congruent, in other words. No. We mean that they have the same angles. Meaning, one more time, this is a common angle to both. So obviously, they have the same angle, A. This is the second common angle because they are both right triangles. Therefore, these must be the same. Because they have pairs of congruent or equal angles, the two triangles are similar. So then now, I can write proportions. Because they are similar, I can write proportions with their sides. I have to start with this common angle. It doesn't matter, actually. Common angle in the small triangle. What is the opposite side of common angle in the small triangle?
BC.
2. Yes, yes, you're right. You're right. But I'm going back to my, yes. Good. What is for the same angle? What is the opposite in the big triangle? Y. Perfect. I'm moving on to this angle, but that will not help me in any way, shape, or form. So I will skip this one. So I'm moving on to these two. First, the opposite side of this angle in the small triangle. I'm so far away from that number. This, if I put it in, I mess up the whole thing. I cannot use this till the last second of the problem, of the solution. This does not exist. So the opposite of this angle in the small triangle
Is X.
excellent. The opposite of the same angle, but in the big triangle.
12.
That's it. That's all I can use. So now, I'm coming back to my question. What am I after? What am I solving this for?
dy over
I have to solve for y, and then dy over dx. Or just cross multiply for now. Xy equals 24. If you say, I don't want to solve for y, that's fine too. Then we will differentiate implicitly. If you want to solve for y, it will be 24 over x. And then we will differentiate accordingly.
I see so.
Okay. So then the left-hand side is dy over dx. And the right-hand side is?
No, it's 1 over, no, negative 1 over
X squared.
x squared. Yeah.
Times 24, very good. Negative 24 over x squared. Excellent. Thank you. Perfect. Well done. So now I can plug in x equals 8. So I get negative 24 over 64. I simplify by 8. So it's 3 over 8. I need to approximate. I mean, I can divide. It's division.
It should be negative 3 over.
Yes. dy over dx is negative what? 3 divided by 8. And I need the measurement unit.
0.375.
Measurement unit.
Meters.
Careful. By mistake, I wrote this, and I messed up the problem. Okay? I messed up the problem. So don't trust me right now. Because by mistake, I wrote x, but I should have written t, because this is a function of t, and then I have to multiply by dx over dt, which I didn't do because I wrote by mistake x. So right in here, I have to multiply by dx over dt, the inner function prime, times 1.6. Forgive me for that. I'm sorry. I wrote over dx, and then so it's t multiplied by 1.6. So careful. We are after dy over dt, not dy over dx, as I wrongly stated here. So dy over dt, which states and tells us already we knew that dx is a function of x is a function of t. So when I differentiate this, the left-hand side is dy over dt, and the right-hand side is negative 24 over x squared times the inner function prime, which is dx over dt, which is 1.6. Everything else is correct, but I had 1.6 in here. So what did we get for dy over dt?
0.6 meters squared.
How much
0.6. 0.06.
is it?
Yeah.
Negative 0.06. Oh no, I'm sorry, no, not 0.6. 0.6.
Okay, so 0.6.
Yeah, sorry.
Very good. Negative 0.6 measurement unit.
Meters per second.
Yes. So as the person walks at 1.6 meters per second towards the wall, the rate of change at the instant at which the person is 4 meters away, at that instant the height of the shadow diminishes by negative 0.6 meters per second. That's the instantaneous rate of change of the shadow at the instant in which the person is 4 meters away from the wall. Okay.